In this lecture, we're going to learn about non-type template parameters. So far, what we have been using are template parameters, and they were things like T here, which are placeholders for types that we pass when we call the function here. If you go down here, you see a simple example of calling this function, and you see that for the second parameter, we are specifying a type as an argument to this function here. That's why these guys are called type template parameters. What we're going to look at in this lecture is non-type template parameters. And you just specify your type directly in your template declaration as we have here. And this is going to be a non-type template parameter. This is basically going to be a placeholder for a value. It's not going to be a placeholder for a type. And when we call this function template, for example, we're going to specify a value for the type. We're not going to specify a type like we are doing for type template parameters here. So in other words, for non-type template parameters, what you specify in your template declaration are direct types that are supported in the C++ programming language. They're not placeholders for types. And this is the syntax we just talked about, but how can this be really useful? Let's look at this function again. This is a function we have set up which is going to tell us if a collection of types is actually valid or not. Suppose we have an array of temperatures here. And for whatever research we are doing, we need to know if a set of temperatures is valid or not. And suppose a set of temperatures is going to be valid if the sum of all the temperatures in our array is greater than 200. And we can use a function like this and specify our threshold for the validity of our array as a non-type template parameter here. And when we do things like this, the threshold is going to be embedded in the declaration of the function here. It's going to be part of the template declaration, and we can specify this when we call the function. This is useful in some scenarios. I personally don't like this because this is going to make our functions a little less readable, but some people prefer this. And this is really what non-type template parameters are all about. In C++20, you have many options for non-type template parameters. They can be any of the basic built-in types in C++, for example, bool, double, float, and any fundamental types. Enumeration types are also supported, pointer type, reference type. You can really use all these crazy things. In C++20, we also support custom types as non-type template parameters. But this is out of our league by now because we haven't learned about custom types. So we're going to skip this for now. But please know that if you are using a version of C++ that is equal to C++ 17 or below, only int-like types can be used as non-type template parameters. If you try to use double and float and all kinds of crazy things, you're going to get compiler errors. Personally, I think that the only types that really make sense for non-type template parameters, at least in the applications I have worked on in my career as a C++ developer, are really floating point types. Class types can be useful, but I haven't really found an application of this, so I'm not going to talk any more about this. In this lecture, we're going to try out integer types as non-type template parameters, and I'm going to show you an example of how you can also use floating point types. Okay, now that we have this in mind, let's head to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is non-type template parameters. We're going to grab our template files and put them in place. And we're going to open this up in Visual Studio Code pretty quick. Let's drag and drop on top of Visual Studio Code here. This is going to open our folder. We're going to open the main CPP file and clean this up a little bit. And we are going to put in our function here. I don't want to type this and waste your time. I'm just going to put this in here and we're going to try and explain this. Our template declaration is going to have a non-type template parameter, and this is how we use this. This is the syntax. You say the type, a type that is supported in C++, and you give your template parameter a name. After that, we have a type template parameter because this is a placeholder for a type we will specify when we call this function here. And the function is going to do its thing. It's going to take two parameters. One is an array of t type. This is a placeholder again for what we will specify when we call this function here. And the second parameter is the size of the array. And we're going to be looping, adding things to the sum variable here, which is going to be initialized to 0 by default here. So we're going to loop around. We're going to grab the element at each iteration and add that to sum. And by the time this loop is done, we're going to have the sum of this entire array stored in this variable here. And we're going to check if it's greater than our threshold here. If it's greater than that, then the array is going to be valid. If it's not, then the array is not going to be valid. This is a simple function we can use to check if an array is valid or not. And we are using non-type template parameters in this function here. This is the meat of this lecture. Okay, now that we have this, we can try this out in the main function. We're going to set up an array of double. It's going to contain a few temperatures from 10 all the way to 50. And we're going to check and see if this array is valid. And we're going to grab the return value of the call to the function. And we're going to say result, for example. This is going to do. And we're going to say is valid. And after the function name, we need to specify our explicit template arguments. The first one is going to be our non-type template parameter. And now this is a placeholder for a value that we will specify when we call the function here. Our threshold is going to be 200. Let's say this, for example. And then we're going to specify the type that is stored in our array. And the type is of double here. So we're going to specify this. And we're going to specify the arguments that we want to call this function with. So the first one is going to be our array temperatures. Let's say this. And the second one is going to be the size of this array here. So we're going to say std size. We can save this. And we're going to say temperatures. And we're going to get the size of this array and use that in our function call here. If we do this, we're going to have a valid C++ syntax. You see, Visual Studio Code is happy about this. Now we can print the result here and know if our guy is actually valid or not. So we're going to say result, and we're going to put this out, and we're going to build here using GCC. You're going to see that the build is good. Again, this is going to generate our template instance for the variables that we specify here. So it's going to be a double instance for this function template, and it's going to be used to compute the sum of these guys, and it's going to return whether it's valid or not. So the build is good. Again, we can bring up a terminal to run this. Let's clear and run Rooster. Now we're going to see that result is 0 because the sum of these guys doesn't go up to 200. Let's sum this up. We're going to get 50 and 40. We're going to get 90. 90 adding 30. We're going to get 120. 120 adding 20. We're going to get 140. 140 adding 10. We're going to get 150, and it is less. So the sum is going to be 150, and it is less than 200. So this array here is not valid. But if, for example, we add in a couple of other elements, let's say 100, for example, now it's going to be valid because the sum is going to be 250, which is greater than 200, and it should be valid now. Let's run this, and we're going to see that result is 1. And if you want to see the output in the form of true or false, you can say std bool alpha, std cout, std bool alpha. I think this is going to do. By the way, this is a manipulator to std cout. And if you don't know about manipulators, please go in the starting chapters of the course. We talked about this extensively. Now the build is good. We can clear, not clear. And if we run this, we're going to see that result is true. Now our array here is valid. And this is how you can use non-type template parameters in your function templates. I have to say I personally don't like using non-type template parameters because they make your functions awkward to use because you have to specify a value as an explicit template argument when you call the function. What I really like to do instead is pass this parameter as an actual parameter to the function. So what I'm going to do is comment this out and show you what I would do instead. Now that you know about non-type template parameters. Okay, so what I would do is something like this. It's going to be a function template, but it's going to take the threshold as a parameter to the function, not as a non-template parameter here. And I'm going to specify this when I call my function, and it's going to be super clear that this is a parameter that we pass to the function. So for example, the call here could change to is valid. We're going to take out the non-type template parameter argument that we passed in here, and we're going to specify the threshold as a parameter to the function here, as an argument, I should say. Okay, now that we have this n, you see the code compiles, and it's going to work exactly in the same way, but now we're not using awkward non-type template parameters here. But this is really your choice. My job here is to show you all these possibilities, and you're going to have to choose what works better for whatever use case you have with the C++ programming language. If we run this, we're going to see that our array is valid, but now it is using function parameters instead of non-type template parameters here. The last thing I want you to see is that you can also use floating point non-type template parameters. Okay, so for example, we can come before main here and put in a function called process. The function has a template declaration on top. You see we have a type template parameter and a non-type template parameter. You see that we are using double here. But this is not supported yet in GCC 10. As you see here, we have a squiggly line. And if we go here, we're going to get a compiler error or an error in Visual Studio Code saying floating point template parameter is non-standard. So this is not supported yet in GCC 10. And if we ignore these squiggly lines and still bold, we're going to get a compiler error. And it's going to say double is not a valid type for template non-type parameter. And this is descriptive enough. I don't think I need to explain this a little more. So non-type template parameters of type double are not supported yet in GCC 10, which is what we are using in this course. But we can use an unreleased version. At the time of recording this course, I am recording this in February 2021. If you are watching this in the future, GCC 11 will most probably have been released because it is planned to be released in May of 2021. So if you are watching this, maybe after that, you're going to have GCC 11 as your compiler, and this is going to work. But if it is before the release of GCC 11, we can use an online compiler like Wandbox. Let's try this. We're going to grab the link here because I have this prepared. So we're going to copy the link and we are going to go to our browser and paste this in. This is going to open Wandbox for us. And again, if you don't know Wandbox, it is an online compiler which is going to have a GCC 11 version handy for us to play with and really do whatever we want. You see, we have our function template here. It has the first parameter as a type template parameter. We have the second guy as a non-type template parameter, and we're going to call the function. It is going to process some data, and it is going to return a times b minus the coefficient here. Suppose this is something useful for whatever it is you are doing in your application. And if you need to do this, GCC 11 you see here is going to allow you to do this. So we can hit run here, and you're going to see that it is going to run and give us the value here, which is 14.5. And we are calling the function with 10 and 2. So this is going to give us 20 if we multiply a and b. And we're going to minus the coefficient, which happens to be 5.5 as a non-type template parameter here. So 20 minus 5.5 is going to be 14.5. And this is working exactly like we want. So this code is not working with GCC 10, but it is working in GCC 11 as you see here in one box. So I am going to come back in our code and comment this out. And I just wanted you to see this. We're going to compile again to get rid of the compiler errors. And now you should have a better idea of how you really work with non-type template parameters. We are going to stop here in this lecture. In the next one, we're going to learn about another cool feature about function templates. Go ahead and finish up here and meet me there.